Right. So in the last class, I have discussed with you about ray diagrams of a concave mirror. Just I am reminding you again how to draw the convex mirror ray diagrams. So first of all, you are drawing the principal axis and cutting the arc using the logic that center of curvature distance. Right. Then make it as a convex mirror. After that, identify its pole and focus. Then here, just I'm giving you logical information here. Do you know any point in front of the mirror? Anyone? Speak out. Any point, noun point. Noun point in front of the mirror. Anyone? Actually, there is no noun point because here it's a focus and its center of curvature are behind the mirror. So there is no noun place, right? So only the noun place is infinity. So any distance it is, right? So always object position, always object position possible between infinity and pole. So just only one ray diagram is possible for the convex mirror, right? That is in between the infinity and the pole. So always the object is placed in front of the mirror above the principal axis. That is the position of the object. So for that, we are completing the ray diagram now. So showing the object above the principal axis and constructing the parallel ray from the top of the object to meet the convex mirror. Then same point we are choosing for one more ray, right? So for this, just join the top of the object and point of instance, just cutting the normal first. After that, we are selecting one more ray. For the second ray, it is possible just the ray which is appeared to meet the center of curvature or the ray directed towards the center of curvature. So for that, I joined the top of the object and the center of curvature and the ray incident on the convex mirror, which is directed towards the center of curvature. Then here we know the behaviors of these two light rays. So first one is what? Parallel to the principal axis. According to the rule 1 of a convex mirror, the ray which is parallel to the principal axis and incident on a convex surface of a convex mirror, then it reflects back that which is appeared to emanate from the focus. So that's why I joined the point of instance and the focus with the scale. Then draw the reflected light ray. So according to rule 1, then see here, I joined that ray in the backward direction with the focus, right? Then next ray, it retraces its path. So for that, just joining the scale by using your scale, center of curvature and the top of the object. Then cut the ray in the backward direction. So this is, so here simply you will observe a common point which is given by the two reflected light rays by R1 and R3 here. So in the backward direction, you will get where they can coincide. That point lie behind the mirror. So from there, what we'll do, just we'll draw a perpendicular onto the principal axis, onto the principal axis. So that is what for us, it is the image point. This is what? Image point. So here you obtained an image point behind the mirror and the facing direction of the image is same as like your object. So simply we will write the characteristics as follow here. So what are the characteristics of the image? We will write as here. Simply the image size is smaller and the facing direction same as the object. So it is erect image, right? Behind the mirror, erect image, that is always virtual image, right? So position we can say behind it is. So virtual image, erect image, diminished image, and behind the mirror positions. So here, if I change the position of the object, here I am moving somewhat closer to the mirror surface. Then what happens if I move the object close to the mirror or away from the mirror? Can anybody expect the characteristics of the image? Anyone from you? Anybody? Can anybody speak out? No one responding. I am audible or not? Just respond. Here object position is changed, right? From previous position to the mirror side. Then what happens? Characteristics of the image I am asking. Do they remain same or changes? So let us check here, right? Let me check how it changes. So here any change in the behavior of ray 1 R1. So R1 is parallel to the principal axis, that is from the top of the object. So it maintains the same direction. So it appeared to emanate from the focus. So no change in this behavior. Then what about the second ray? Second ray, this appears to meet center of curvature and it is changing its direction in reverse side. So sent back, right? Then we have to take a ray that in backward direction, so extending it to meet center of curvature. So I'm using different color here. Now anybody write the characteristics for the second position here for this object. Characteristics. Anyone? Rohit?
Sir,
Characteristics for this position.
virtual image,
Why virtual? Why you said virtual? Here to say virtual image, we have one reason that light rays after the reflection itself, they are going to coincide or by the backward rays. So actually they are coincide means that is real image. If they are by the backward rays or backward extension, then virtual. I think you are clear. What is virtual? Right? How to identify the virtual image in the ray diagram? By the light rays coincides that point. Is it by the actual rays or the backward rays? So backward rays or which it is virtual, right? So virtual is correct. Then what about the remaining?
diminished,
Diminished because smaller image. Okay, next.
behind the mirror,
Behind the mirror. One more. Based on the direction.
erect image,
Right. So no change in the characteristics. So for the first position, what I got the characteristics, right? For the second position also, I got the same characteristics. Are there any difference in the characteristics of the image? No difference, right? So here, for any position, irrespective to the position of the object, characteristics are fixed for the convex mirror image, right? characteristics of the image formed by the convex mirror always same. Any confusion, then ask me. Otherwise, use your quick reaction. Why the characteristics are fixed. So everyone is clear? Right. Savan, Kaushik. Okay. Right. Next, we will go for another topic. That is here simply derivation of a mirror's formula. Derivation of a mirror's formula. So for this, just for the derivation purpose, I am going to imagine a situation that object placed in front of a mirror beyond the center of curvature, right? So I am considering a situation, object placed in front of the mirror beyond the center of curvature. Which mirror is it? Can you name the mirror? I said the position of the object beyond the
concave mirror.
Beyond the center of curvature. Why concave mirror? Why not convex? So in front
Sir,
of
we have
come.
We have some positions to place the object in front of the mirror.
The known places or points only located in front of the concave mirror. So that's why it is concave mirror, no doubt at all. So I'm taking center of curvature, then cutting the arc using somewhat radii of your compass, then identifying the pole and center of curvature using the logic 50-50. That means midpoint. So focus is identified. Where we placed the object? We are going to place the object beyond the center of curvature. So here to complete the ray diagram, how many rays are needed from the same point of the object? Number of rays.
2.
2 from the top of the object. So one is here. I'm naming that object as AB, right? So AB is object. Then here what to do? Simply we have to select 2 rays from the top of the object. So one is parallel to the principal axis and the other ray which is passing through the focus, right? So here, first of all, I have shown a mirror point on the mirror surface, right? So here, for what purpose? Where it is going to meet the principal axis. That means point of incidence. Point of incidence I have shown on the mirror surface now. Then secondary. So here secondary I am considering through the focus, sorry, through the center of curvature, that is R3. Right? R1 and R3 is considered. What are the characteristics of the image? In this case, you obtained in the previous ray diagrams. Can anybody? Characteristics I need. What the characteristics we got? In case of object placed beyond, or you have the textbook page number, end of the textbook, you have one table. If you place the object beyond the center of curvature, characteristics are real, inverted, diminished, right? Between F and C. So we will check that because I changed the combination of rays. Previously I used R1 and R2. Now I'm using R1 and R3, right? So here we know that behavior of a parallel ray, right? Behavior of a parallel ray. How it behaves? So one of the ray R1 incident on the concave mirror at a point X, and the second ray R3 incident on the mirror at a point Y below the principal axis. Then what happens after reflection? So parallel light ray passes through the focus. Then R3 retrace its path, right? So it is retrace its path. See, again, it is passing through the center of curvature. See, right? Then here I got a common point after reflection. Can anybody write the characteristics for this image? Say the characteristics. Image point is shown. Characteristics. Don't waste the
Real
time.
image.
Real image. Next, say all the four.
Image.
Real image,
Inverted image.
inverted image,
Diminished image.
diminished image. Position,
Between focus and center of curvature.
right. Any change in the characteristics of the image obtained by changing the combination. You have this diagram in the page number 9, figure number 12. Textbook, page number 9, figure number 12. Check the characteristics. So taking any combination, but ray diagram's characteristics, you will get the same. But if you draw a ray diagram, follow the first two combinations only, R1 and R2. If not possible, go to R3 combination. Okay, right? First combination is R1 and R2. Next combination is R1 and R3. So for the derivation purpose, I am following this logic, right? Then I got the characteristics. So here I shown the object at a point A, and AB is the height of a object. Okay, then image point I am identifying as A dash, and top of the image is B dash. So A dash B dash is the image of AB. A dash B dash is what? Image of object AB. Then what I am doing here, at a point X on the mirror, concave mirror, I am drawing a perpendicular line onto the principal axis. As you see here, pink color line, vertical to the principal axis from the point X, right? Then here I am naming that line where it meets the principal axis as a P dash. The point identified as P dash. So pink color line is what? It is vertical, perpendicular to the principal axis. Vertical line drawn from the point X onto the mirror. So P dash, it coincides at a point P dash. Then here simply I am going for the derivation part. So I have shown that ray diagram is smaller here. So can anybody find the similar triangles in this? Do you know first similar triangles? Anybody? Give me your response. Similar triangles. What are said to be? What triangles are said to be here? Similar.
Similar shape.
Shape, same. Okay. Any other?
The ratio of sides.
No. That is actually proof, not the definition or not explanation for similar triangles. So here similar triangles means shape same, right? Its outline is same, but size
different.
very good. Size not same. Then they are
Sir,
said to be similar triangles. So now name the triangles.
XB B dash B F C B dash.
So take right angle at middle of name. That point is middle in the name of triangle. Then one more also I am giving you logic. Opposite angles must be equal. Angles opposite to each other, they are equal. So select based on the opposite angles.
P dash X F, A dash B dash F.
Okay, this is one of the combination. Any name you can take, no problem. Okay, one you are said X P dash F. So here angle is there. Here its opposite angle is this one, right? So another one is triangle F
A dash B dash F.
and B dash. So another possibility is there. One more pair of similar triangles available with opposite angles. See here, right angle triangle.
ABC.
Triangle. So it is A dash, B dash, C and ABC. Is it clear? How I found that similar triangles based on the shape same, size is different. Especially I used right angular triangles. Right? Especially I used right angular triangles. Just a second. Venkatesh, నేను క్లాస్ తీసుకుంటున్నా అక్క దాంట్లో గేసి మాట్లాడు ముఖ్యపేట చిన్నక్కకు మాట్లాడు okay. So I'm came back, right? So here I'm going to note down first similar triangles. So first I'm finding that triangle ABC and triangle A dash B dash C are similar triangles. Any doubt? Any doubt? So clear everyone, right? So these are the similar triangles. So in the similar triangles, we have one proof. That is what? Ratios proof. Can you say anyone that what the relation we have with the ratios from the similar triangles? Ratio of
Sides.
what sides? What sides? Corresponding sides. S ratio of corresponding sides equal. So for that we are going. So here in the triangle AB, just I am selecting the base. Sorry, it's a vertical line or a height. What is height in that triangle? AB is the height, right? So what is its corresponding side in the opposite triangle? That is A dash, B dash. So AB by A dash, B dash is equal to, now I'm taking, that is, it's a base from the first triangle. Base is what? AC by A dash C. So this I am identifying as equation 1. Any confusion in this to anyone? Corresponding sides ratios are equal from similar triangles relation. We used that. Then I'm going for one more set of similar triangles. That is, sorry, double triangle written. Okay, triangle P dash XF and triangle P dash F are similar here. Right? So using the same logic, what I can write? The relation we can write from the triangle's second set. Here it is P dash X by A dash B dash is equal to P dash F by A dash F or F A dash also, no problem. Right? So this is one of the relation I got. But here, what is P dash X equal to? From the entire diagram, can anybody? Is it equal to any other parameter? P dash X is equal to any other parameter? If it is equal, why? How you choose it? Answer me. So what is actually P dash X? It is giving you length between
P and X.
also parallel lines, what they are? The gap between the
PX and BA.
no. Vertically here it is. This side you are observing. This is principal axis. This is incident ray, right? How they are parallel to each other. So this gap exactly equal to what? P dash x is equal to what? AB.
Sir, AB.
Why? Why? AB is correct. Why?
Sir, they are parallel to each other.
Very good. So parallel distance at any point you measure, it is equal. So what I know, P dash x equal to what? AB. Shall we replace in this equation? P dash x. So I am replacing this P dash x by AB here, right? So what I will write? P dash x equal to AB we are substituting by A dash B dash as is equal to P dash F by A dash F. Up to here, everyone clear? Any confusion? Okay. So up to here is very clear. Then we will go for next. Observe the equation 1 and the equation 2 here. What you notice from the equation 1 and equation 2? What do you notice? Equation 2 is here. From equation 1 and equation 2, do you have any common? LHS side, RHS side. So here LHS in the equation and LHS in the equation 2 are same. Are you clear? What I told you? From equation 1 and equation 2, LHSs are same. So what we can do mathematically?
P dash x is equals to A by A.
P dash x equal to AB is substituted. There is nothing to substitute here because P dash F is there in the equation 2. LHS in the both equations are same. Right? Here, suppose it is A, this is B, this is also A, this is C. So here how it is looking like mathematical relation? Mathematical relation.
P dash F is equals to AC.
P dash F equal to AC. No. Here not like that. Here we have mathematical relation. Suppose A equal to B. If B equal to C or A equal to C, what we can write? Third relation. If C here, then B equal to C it is. Like that, what I can write here? Simply,
AC by A dash C is equals to P dash F by
very good.
A dash F.
AC from equation 192, I am able to write AC by A dash C is equal to P dash F by A dash F. So this is actually RHSs making equal if LHSs are same, right? So now here I'm going for a new concept, that is paraxial rays. So what are actually paraxial rays means? If this parallel ray I brought very closer to the principal axis, what happens? So I will show you the ray which is parallel to the principal axis. Instead, on a mirror, very close, what happens? Can anybody observe what happens in this case? See here, the point I will show you. The point I will show you here on the mirror. On the mirror. Look at that, a blue color spot. It is very, very, very closer to the point P. Yes or no? P dash becomes close to P. If this ray further brought near to the principal axis, very close, what happens? Here P dash may coincides with the point P. P dash may coincides with point P. Are you clear? If we assume that the incident light ray, which is parallel to the principal axis, very close to the principal axis. Just imagining this ray, what happens in this case? P dash exactly meets P. So that's why what we'll say here, P dash X is becoming 0. We cannot consider it is, right? So here what happens? P dash F or P dash A dash or P dash C or P dash A. Any measurement you are taking, this P dash will be replaced by P. So P dash is equal to PF we will take, or P dash A dash equal to, we will take PA dash. So no point P dash here. Are you in confused? Are you in confusion? What I'm saying, are you clear? Speak out if there is any confusion or quick response. Right? So here simply the ray which is very close and parallel to the principal axis, that ray is called as paraxial ray. So paraxial rays are nothing, rays which are parallel to the principal axis and very, very closer to the principal axis. That ray is only called as paraxial rays. So everyone is clear what is parallel? Sorry, what is parallel paraxial ray? Paraxial ray. Clear? Speak out or use your quick response. Paraxial rays. The rays which are parallel to the principal axis and very closer to them. Right? They are called as here paraxial rays. Right? So we have 5 minutes only in this meeting ID. Okay, we will continue. So if P dash is coincides with the P, what we can write here? P dash F equal to, we can write PF. So no P dash point here. That distances may become equal. So P dash F will be replaced now as PF. So what we can write from this equation? This equation. From this equation, we can write here AC by A dash C is equal to P dash F is replaced by now PF. So PF by A dash F. Any confusion? Any confusion? Clear everyone? Just I replaced P dash F using a concept paraxial rays. So that's why P dash F is written as PF now. Then what happens from this equation? So here I'll go for noun places here. Okay, let me check your understanding level. Just tell me the gap, the length we are measuring between P to F. We can name or call it as, we have definition, the length between P and F.
Focal length.
Focal length, very good. If I measure the length between P to C,
Radius of curvature.
very good. Then I am measuring the length between pole to the object. What distance we can call?
Object distance.
Very good. Object distance. Pole to the image.
Image distance.
So anybody in confusion? Pole to the object is object distance. Pole to the image is image distance. Pole to the focus is focal length. Pole to the center is radius of curvature. Any confusion in these definitions? Just these are measurements, parameters. Quick reaction or speak out. Right? So everyone almost clear. Right? So this is object distance denoted by U. Then here you have the length between P to C is denoted by R, radius of curvature. Then here pole to the focus is denoted by focal length F, and pole to the image is image distance by V. So these are the parameters we know, right? So here simply that the parameters, here we have in the relation what I got here. What is PF? Pole to the focus distance. So what we can write? PF equal to pole to the focus. F we can write. A dash F is what? We don't know. AC equal to what? We don't know. A dash C equal to what? We don't know. So we have to find it with the noun places, right? We have to find the unknown values by the noun places. Okay. So I'm closing this meeting. Immediately you can join using the same link in the meeting again.